Okay, in 6.1 we're going to be studying similar polygons. So we have some vocab to work on. So it's the first thing says similar polygons. Two polygons with corresponding angles that are congruent. Okay, so I'm going to put the congruent symbol here. It's the equal sign with the little other shape on top. And they're also going to have corresponding sides in proportion, which means in the same ratio. So this is called a similarity statement. Okay, and what that's telling us is that angle A is going to be congruent with angle E. Okay, so A is congruent with E. B is congruent with F. See how I'm reading the letters and matching them up? C is congruent with G. And D, I'm going to try to make, well, maybe I'll do something like this. Then I'll just change the color. So let me just change that color. That is congruent with H. Okay, so that's my congruency that I got from my similarity statement. Okay, the scale factor tells you how the sides are related to the sides of the other shape. Okay, so for example, I have a ratio for A, B, C, D, and E, F, G, H. I'm not sure what that is, but I can do my proportions. So AB is to EF, I'll say, EF, just like what comes next, BC is to, and BC goes with FG, just like CD goes with GH, and that is just like AD goes with EH. So they are all in the same proportion. That proportion is called the scale factor. So the scale factor is defined as the ratio of the lengths of two corresponding sides. And you can always reduce that to the simplest fraction. Okay, let's go on, and we're going to fill in about the first theorem. So the theorem deals with the perimeters of similar polygons. So if two polygons are similar, and here's our shape for similar, then the ratio of their perimeters is equal to the ratio of the corresponding sides. So for example, if let's say the red to the blue is in a ratio of 1 to 2, okay, that's their scale factor. So the 1 goes to this and the 2 goes to the blue, then the perimeters will be in the same ratio. So let's say the perimeter of the red shape, the red quadrilateral, was 20, then the perimeter of the blue would be 40, because that's a 4. Let me just make sure that looks like a 4. It's going to be 40 because it's going to be in the same ratio. So 20 over 40 reduces to 1 over 2. Okay, let's go on to the next page. Okay, this is a continuation of what I was just speaking about. So we already know that we have these words in here, similar and perimeter. So I went over the theory on the other page, and here I've written it all out, matching up the colors. So that should help you understand what I just said on the previous slide. So the key concept at this point we want to talk about, corresponding lengths in similar polygons. So if two polygons are similar, and here's the similar symbol, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygons. Okay, so that ratio is your scale factor. Okay, let's go on to the next page. Okay, here's example 1. So we're going to use the similarity statement. In the diagram, triangle RST is similar to triangle XYZ. So go ahead and write your similarity statement. So you should be writing RST is similar to XYZ. And I'm going to just change color. And I'm going to say that order, excuse me, order matters. So order matters. Okay, so order matters in this situation. So first thing they're going to ask us to do is to list all the pair of congruent angles. Now, I like to do that from the similarity statement, because then I don't get confused in case the orientation of the figure is different. So looking at the similarity statement, which is right here, what I would say is angle R is equal or congruent to angle X, matching up the first letters of each triangle. Angle S is congruent to angle Y, and angle T is congruent to angle Z. Okay, so make sure you understand that. Okay, next I'm going to check that the ratios of the corresponding side lengths are equal. So again, looking at the similarity statement, RS is 20. That should be proportional to XY, and XY is 12. That has to equal, so let's see. ST comes next in my similarity statement, so that's going to be ST is going to be 30, and that has to be similar to YZ, which is 18. And that leads us to our last pair, TR, which is 25, and ZX, which is 15. So these look very different, don't they? Let's see if we can reduce them. Now, I'll tell you something else. If you just divide 12 divided by 20 divided by 12, 30 divided by 18, and 25 divided by 15, you should get the same decimal. And that's another way to handle that. So go ahead and make sure you can get the same decimal. So go ahead and do that division, and then check what I have when I do the division. Okay, when I did my division, I got 1.6 bar notation for each of them. So I know they're in the same proportion. But now let's get that scale factor as a fraction. So why don't I just work with this last one? So 5 goes into 25 5 times, and 5 goes into 15 3 times. So that is my ratio. That is my scale factor. Okay, a word about that. When I did my division and I got 1.6 bar notation, if I went second math, if I went math and I turned that into a fraction, you should be getting 5/3. So either way, whether you have it as a decimal and then turn it into a fraction, or just reduce it by putting the greatest common factor in each, the numerator and the denominator, you will get the same answer. Okay, let's go on to example number 2. It says, determine whether the polygons are similar, and if they are, write a similarity statement and find the scale factors of the two shapes. Okay, so looking at that, look at your angles. F equals Z, J equals W, X equals H, and Y equals G. So yes, those are similar because the angles are all congruent, so that'll do it for us. So write your statement. So let's see what we get. Matching up the angles, I get F, J, H, G is similar to Z, W, X, Y. So make sure that your angles all match up. Okay, so now to get the scale factor, since I know the angles all match, I'm going to just pick one fraction and get the scale factor from that. So how about if we take 16 is to 20, because Fj is proportional, so Fj is proportional to Zw. Okay, 16 20s. 4 goes into the numerator 4 times. 4 goes into the denominator 5 times. 4/5 is our scale factor. So, the nice thing about scale factors, I know right away that my sides are in that proportion, 4 to 5, and also my perimeter is in that proportion. So if I would add up all the sides from the first shape and add up all the sides from the second shape, that will be in proportion of 4 to 5. Okay, let's go on to example number 3. Okay, here's example number 3. And it says in the diagram, triangle DEF is similar to triangle MNP. Okay, so go ahead and write your similarity statement. So DEF is similar to MNP. So now let's get our ratio. So I see that X is on the EF. So X is to EF goes with NP. So X is to 20, just like ED, which is 9, is to MN, which is 12. Okay, so now a couple of things. You could just do the cross products, and if I did that, I would have 12x equals 180. And then I could solve for x. So 180 divided by 12, using your calculator, I'm getting 15 for my x. Okay, so x is 15 in this situation. What if I had reduced the fraction? Would that have made this easier for me? So 9/12 is the same as 3/4, and then I would have gotten 4x equals 60, and x equals 15 that way. So if you want to reduce your fraction first, you can, just as long as you do that carefully prior to doing your multiplication. So let's go on to example 4 on the next page. Okay, example 4 says a town is building a new swimming pool. An Olympic swimming pool is rectangular with length 50 meters and width 25 meters. The new pool will be similar in shape but only 40 meters long. Okay, so here's your new pool. This is 40, but this is x. They told me it's going to be similar. That means that they're going to be in the same ratio, the sides are, that is. So it says find the scale factor of the new pool to an Olympic pool. Okay, so the only numbers we know on the new pool is the 40. So I'm going to have to say, and they want new pool first. Okay, that's key. New pool is first. So if new pool is first, then I have to write this as 40 over 50. Okay, new pool to Olympic pool. That is critically important. Then I would take that scale factor and I would reduce it to 4/5 by dividing both the numerator and the denominator by 10. Next they say to find the perimeter of an Olympic pool and the new pool. Alright, so the Olympic pool, I know that the opposite sides will be the same because it's a rectangle. So I have Olympic will have a perimeter of 50 plus 50, so we'll add these up. 50 plus 50 plus 25 plus 25. So that is a total of 150. Okay, now, I could work out the whole proportion, find the x, and then add everything up for the new pool, or I could work smart. I know that new pool to Olympic pool is in the ratio of 4 to 5. So I know that the perimeter of the Olympic is 150. That goes with the 5, so it's in the denominator. So now this missing value will be the perimeter of the new pool. And remember, it's going to have the same scale factor, so there's no reason to do all that math. You can go ahead and use the scale factors. So say 4 times 150 has to equal 5 times this perimeter new, and do that on your calculator. So 4 times 150, and then divide that by 5, and I am getting the fact that the new pool will have a perimeter that's going to be equal to 120 meters in length. Okay, so if I add up all the 4 sides, that's what I would get. But I didn't do that. I used the scale factor instead. Okay, let's go on to example 5. In example 5, we're going to use the scale factor. So it tells us that triangle TPR, so TPR is similar to triangle XPZ. So find the length of the altitude segment PS. We're going to make that an X. So, a couple of things. The nice thing about similar shapes is that all the corresponding parts are in proportion. So therefore the altitudes will also be in proportion. They'll be in the same proportion as are the sides. So if I know, for example, that 8 is to 6, okay, so the bases, well, I guess, what should I do? Maybe I'll do 16 is to 12, so we'll figure this out a couple of different ways. Okay, so this is the ratio I've set up. So it's right here, and I've said, okay, this base 16, 8 plus 8, is to this base 12, just like the left triangle's altitude is to the right triangle's altitude. So then I say 16x equals, okay, 20 times 12 is 240. So therefore divide both sides by 16, and you're getting x equals 15. And that's using the scale factor to find the altitude. Alright, here's some extra practice. In this diagram, ABC is similar to triangle DEF, so write that similarity statement. ABC is similar to DEF. Okay, list all pairs of congruent angles. So A is equal or congruent to angle D, that's A, and then angle B is congruent to angle E, and angle C is congruent to angle F. Check that the ratio of corresponding side lengths are equal. Okay, so let's check that out. So AB, which is 25, is to 35, just like 20 is to 28, and just like 30 is to 42. So the first thing that you could do, if you wanted to, is you could do all of those divisions. So 20 divided by 28 and 30 divided by 42. Okay, I'm seeing that I have the same exact decimal each time, and that is 7.1428571. Okay, so I know that those are all going to be in the same proportion. Now let's go ahead and figure out the scale factor by reducing one of these. So I know that 6 goes into both 30, goes in 5 times, and into 42, 7 times. Since I have my decimal in my calculator, I can say math, fraction, enter, and I should be getting the same fraction 5/7, which I have indeed gotten. So you should check that for yourself. So here is my scale factor in simplest terms as a fraction. Okay, let's go on to the next problem. Okay, here we are, extra practice number 2. So this says determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. Look at the angles. I am seeing that R equals D, S equals E, T equals F, and U equals G. So let me just scoot this over just a little bit, and then we will have our similarity statement. So this was RSTU, and that's similar to DEFG, lining up the angles that are equal. So yes, I can say that they're similar. So now find the scale factor. So because I know they are indeed similar, you can just pull one ratio. So how about if we say 30 is to 20? Now remember, this has to come first. This is going to come second. So that scale factor ends up being 3 to 2 when you reduce by dividing both the numerator and the denominator by 10. So let's go on to the next page. Okay, here it says in the diagram, triangle ABC is similar to triangle GHJ. So let's write that similarity statement. ABC similar to GHJ. Okay, find the value of x. Well, it looks to me like 12, which is from the ABC, is to 8, just like x is to 16. So what am I going to say? 16 times 12, using my cross products because these are equal. 16 times 12, and then divided by 8, and I am getting an x that equals 24. So this x is 24, using the fact that I have a scale factor and the triangles are similar as indicated. Okay, so next thing, you are constructing a rectangular play area. So here's a rectangular play area. And the playground is rectangular with length 25. Excuse me, let me just write that again. 25 meters and width 15 meters. The new play area will be similar in shape, but only 10 meters in length. Okay, so I'm going to do a new one, and it's a little smaller. It'll be similar. This is 10. I'm not sure what this is. Find the scale factor of the new, so that's the smaller one, to the playground. Okay, so the new one is 10, and the old one, or the playground itself, is 25. Okay, so what can I reduce this to? So 10 over 25, 5 goes into 10 2 times, 5 goes into 25 5 times. If I couldn't do that, I could say 10 divided by 25. I get a decimal, and then I can say math, fraction, enter, and I get the fraction 2/5. Okay, so that's done. All right, next they want to know about the perimeter. Find the perimeter of the playground and the play area. So I know that's on the next slide for me, but I'm going to do that work over here since I have my picture here. So first off, find the perimeter of the playground. So that's the whole big one. So if I know the length is 25, I know the top is 25, and the side is also 15. So add up those four numbers. So I'm going to say 15 plus 15 plus 25 plus 25, and that equals 80. So the playground has a perimeter, adding everything up, of 80 meters. Now I could calculate all of the play area measurements and add them together, but I'm not going to do that because I know that the new play area to the playground has a scale factor of 2 to 5. So the playground was the 5, so put the perimeter of the playground the playground on the bottom, and then the smaller number will go on the top. That'll be the perimeter of the play area. So go ahead and do that math. So 80 times 2, was 160, and divide that by 5, and I am getting a perimeter of 32 meters. Okay, so the inside is 32 meters in perimeter, the outside is 80 meters in perimeter, and I determined the smaller perimeter by using the scale factor of 2 to 5. So that ends the 6-1 notes.